All right, so 12.2 is on permutations and combinations. All right, so we start off talking about factorials. All right, so factorials, the exclamation point in mathematics, it means factorial. So it means you just take that number, count down by ones until you get to one, and you multiply all of those numbers together. So that means if you had 100 factorial, that would be 100 times 99 times 98 times 97 times 96, all the way down to 1. And then, like I said, you multiply those together, that would be your factorial. 1 factorial is equal to 1, and also 0 factorial is equal to 1. All right. So, small example of that, 4 factorial, just 4 times 3 times 2 times 1. Multiply those together, will give you 24. So, in this section, you could have something that asks you to evaluate. I'll show you the short way and the long way of doing this type of problem. Also, if you know how to use a calculator, or if you need help with using your calculator, make sure you get with me. If you know how to use your calculator, then feel free to do so. Not really challenging the process, especially with a situation being what it is. So if you know how to use your calculator, then that is fine as well. Pretty much most scientific calculators have this factorial function. You just have to look for it in some cases, and in some cases it's actually sitting on the front of the calculator. But like I said, if you need help with your calculator, make sure you contact me and we'll do that. So 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. 5 factorial is 5, 4, 3, 2, 1. 5's cancel, 4's cancel, 3, 2, and of course 1. And you're left with 8 times 7 times 6. That's 336. Now that's the long way of doing this, because if you had 100 factorial over, let's say 98 factorial, what you do not want to have to do is write out 100 numbers and then write out 98 numbers in order for you to see the process. So here, notice we had 5, 4, 3, 2, 1. And here we have 5, 4, 3, 2, 1. And that represents 5 factorial. So within that 8 factorial, what this is saying is that we have 5 factorial. So the short way of doing this is recognizing that down bottom, I have that smaller number. From here, that all cancels. And you're left with 8 times 7 times 6. All right. So if I had, like I mentioned, 100 factorial over 98 factorial, that would be 100 times 99 times 98 factorial over the 98 factorial. That cluster of products cancel. That leaves me with 100 times 99, which is just 98. Oh, excuse me, 9900. All right, questions? All right. Another one you may see is 5 factorial minus 3 factorial. We cannot subtract them from each other and get 2 factorial. We have to expand it out. 5 factorial is 5, 4, 3, 2, 1. Multiply by 3 factorial, 3, 2, 1. So that multiplication is 120. 3 times 2 times 1 is 6. So that'll be 114. Questions? Any questions? All right, so permutations is an arrangement of items in which the order matters. So there's a formula for it. the permutation of n things taken r at a time. So the notation is npr. So it'd be n factorial over n minus r factorial. So the key here is the arrangement of items in which the order matters. Combinations, we'll come to realize when we get to combinations, we'll see that the order does not matter with the combinations. And so when we talk about n things taking r at a time, so in other words, let's say if I have 30 students, I want to know how many different ways could I take them to, or pick 5 out of the 30 to take to a conference. So how many different ways could I choose 5 out of 30? So 30 students taking 5 at a time. N is always your larger number between the two. All right, so a university tennis team consists of 6 players who are ranked from 1 through 6. If a coach has up to 10 players from which he can choose, which to choose, how many different ranked teams can the coach select? Okay, so a couple different things here that we need to make sure we point out, which will dictate how we operate moving forward. We have a ranked team from 1 through 6. That means the order matters. All right, if you're talking about ranking 1 through 6, the order matters. So we have a coach that has 10 players from which to choose from. So you're going to choose 6. And that's what it says right here also, 6 players out of the 10. So remember I mentioned your larger number is always your n. Smaller number is 6. Try and do 6 out of 10. And because it's ranked, that means we're doing permutations. So it's 10p6. It's 10 factorial over 10 minus 6 factorial. So do this in parentheses. 10 minus 6 is 4 factorial. And you should be able to throw it in the calculator. If not, you're going to take that 10 down to 4 factorial. because of what's in your denominator. That 4 factorial cancel, leaving you with 10 times 9 times 8 times 7 times 6 times 5. And multiplying those numbers together, your final answer will be 151,200 different ways. You can choose 6 out of that 10. All right, any questions? All right. All right, in 2015, 18 horses were entered in the Kentucky Derby. How many different finishes of first through fourth place were possible? So once again, we're looking at first through fourth or first through something. We're looking at a ranking, which means the order matters. And we have 18 horses. So that means N is 18, R is 4. All right, so 18P4. And do the work on that, you get 73,440. All right, one more dealing with order. All right, so we have 5 women. Yep, and that should be an E, right? So 5 women and 4 men are to be seated in a row of 9 chairs. How many different seating arrangements are possible if there are no restrictions on the seating arrangement? So we'll look at that one first. We have an A and a B. And this one we can do a little differently, just to help us get a visual on how we can do this. We have 9 people all together, 5 women and 4 men, and there are no restrictions on seating arrangement. So if we have 9 boxes, so we have 9 boxes that represent each seat. In the first seat, I have 9 people to choose from. Once that person sits down, after that, I have 8 people to choose from. Once that person sits down, I have 7 people to choose from. 6, 5, 4, 3, 2, and 1. So what goes in the box or each seat is the number of options to choose. All right. So in each box, you're talking about the number of options. So once you've done that, then you just multiply those numbers together. You notice that we have 9 factorial. You have 9 counting all the way down to 1. Multiply those numbers together. And that's going to be 362,880. All right. Questions on that? All right, then we want to know the number of options or different ways that we can set it up so that the women sit together and the men sit together. All right, so we'll set it up again with our 9 chairs. So there go our 9 chairs. So if we're talking about the women sitting together, we have 5 women and 4 men. So in the box, we would go 5, 4, 3, 2, 1, because they have 5 women to choose one all together. And then for the men, we would do 4, 3, 2, 1, because we have 4 men to choose from all together. All right, multiply those together. And that should be 2880. Now that's not my finished answer or my complete answer because we're talking about the women sitting together and the men sitting together. So this first option explores the women sitting first and the men sitting second. Next, we will look at the men sitting first and then the women sitting second. because the goal is for you to have the men sitting together and the women sitting together. Didn't say which group or which cluster had to sit first. So this is our men, this is our women. So 4, 3, 2, 1. 5, 4, 3, 2, and 1. If you multiply those together, you should get that same number of 2880. So then add them together. 2880 plus 2880 is 5760. All right, questions before we look at combinations. All right, combinations are a collection of objects in which the order matters. All right, NCR, n factorial over n minus r factorial times r factorial. So it's very similar to NPR, just that it has an extra r factorial in the calculation or in the formula. Collection of objects in which the order I put matters. Sorry about that. That should be does not matter. Permutation was matter. Sorry about that. So a collection of objects in which the order does not matter will be your combinations. Permutation is when the order matters. Combination is when the order does not matter. All right, so an emergency room at a hospital has 11 nurses on staff. Each night, a team of 5 nurses is on duty. In how many different ways can the team of 5 nurses be chosen? So you're just talking about 5 nurses. There's no ranking. There's no best nurse to least nurse or anything like that. So the order does not matter. So just like before, when we were dealing with permutation, you want to know how many of a larger number can you take a smaller number. It's the same type of thought process here. We have 11 nurses, and we know how many different ways can we choose 5 out of the 11 nurses. So that means n is 11. Remember I said n is going to be a larger number. R is 5. That's 11c5. 11 factorial over 11 minus 5 factorial times 5 factorial. So 11 factorial divided by 6 factorial times 5 factorial. You put that in the calculator, should get 462. Depending on the type of calculator you have, you may need to put parentheses around that. All right, questions before we look at least one more. All right, a committee of 5 is chosen from 5 mathematicians and 6 economists. 3 different committees are possible if the committee must include 2 mathematicians and 3 economists. Excuse me. So when you look at what's going on in this problem, you have a committee of 5. We have 5 mathematicians. Out of those 5 mathematicians, 2 is supposed to be a part of the committee. And then we have 6 economists. And out of those 6 economists, 3 are supposed to be a part of the committee. So we have two different groups here, and we're trying to figure out how many different ways can we choose a certain number out of each group. So I want to be able to choose 2 out of the 5 mathematicians, because those 2 mathematicians will not come out of the group of economists. So that would be 5C2, which is 10. After you put in your calculator. Then you have your economist, and we want to choose 6. Well, you want to choose 3 out of the 6, excuse me. And 6C3 is 20. All right. Take both of those, multiply them together. And you have 200 different ways that you could create those committees. All right. Questions on what we did. So just doing a recap on that problem, we had 5 mathematicians and 6 economists. We wanted a 5 person committee that had 2 mathematicians and 3 economists. So we chose 2, or figured out how many different ways could I choose 2 out of the 5 mathematicians, and how many different ways could I choose 3 out of the 6 economists. 5C2 ended up being 10, 6C3 ended up being 20. Once you get those two numbers, multiply them together, and that will be how many different ways you can choose 2 mathematicians and 3 economists. All right, questions on that? Concerns, comments before we close out? All right, sounds good. Thank you for the response. So with that being said, that's it for today. Have a good day. Hope everyone have a great one, and I will see you on Wednesday.